Okay, so here we go. The first one we're going to talk about is number one. The market portfolio's historical returns for the past 3 years were 10%, 12%, and 17%. Suppose the risk-free rate is 4%. Estimate the market risk premium. What is the market risk premium? It's the expected return on the market minus the risk-free rate. We've already got the risk-free rate, so all we need to do is calculate the expected return on the market. How would I do that? Yeah, you just find the average. So I'm going to take 10 plus 12 is 22, plus 17% is 39%, divide by 3 gives me 13%. And 13 minus 4 is how much? 9%. Is that the correct answer? Ooh, very good. Okay, now let's talk about number two, the annual return on the S&P 500 index was 11.9%. The average T-bill yield during that same period was 5.6%. What was the market risk premium during that year? Once again, market risk premium is just the expected return on the market minus the risk-free rate. What are we going to use from here as our stand-in for the expected return on the market? So the S&P 500 index. That's going to be 11.9%. What's my stand-in for the risk-free rate? Yeah, the T-bill, 5.6%. So I take 11.9, subtract 5.6, I should get 6.3%. Is that the correct answer? Okay. Now we are on to number 4. The geometric average of negative 9%, positive 20%, and positive 23% is. Okay, first thing I have to do is I have to realize when I do geometric average that I have to use decimals. I have to use decimals. And so what we're going to do is take 1 plus each one of those decimal returns. We're going to multiply all those together, and then we're going to raise it to the 1 over n power. What is n here? 3. So let's get started. 1 minus 0.09. Do you see that that's the same as 1 plus negative 0.09? Okay, so there's 0.91. I'm going to store that in location 1. And then I can just do this one in my head. 1.2, store location 1. 1.23, store 3. I think I screwed up the second one. 1.2, store 2. And then 0.91, store 1. So then all I've got to do is say recall 1 times recall 2 times recall 3. So that's all my 1 plus r terms multiplied together. Now what was the next step? Yeah, raise. So we're going to go y to the x, open parentheses. 1 divided by 3, because n is 3 here. And say equal to. What is my next step? Yeah, I got a minus 1. And then just to make it back to 100 or for percent, I'm going to multiply by 100. I'm getting 10.34%. Is that correct? Okay. Oh, saddened that you guys don't want to hear about sexy socks. Okay, here we go. What's that? No, that's okay. The past 5 monthly returns for Kentucky Jelly are 3.25%, 7.13%, negative 3.05%, 4.25%, and 6.75%. What is the standard deviation? What's the easiest way for us to do this? Yeah, use the calculator. We're going to go second, number 7, and then I'm going to say second clear, because I want to get rid of all my previous data. So here we go, 3.25, enter, arrow down. What do I do here? Skip it. X02, 7.13. Enter. Arrow down. Just skip it. Arrow down. 3.05. Negative. Enter. Arrow down. Arrow down. 4.25. Come on. Enter. Arrow down, and then finally 6.75. Enter. What do I do next? Second, and the number 8, which is stat, and it says lean, and we're going to arrow down, and it's equal to 5. Is that right? Yep. That's your first check. Next, it says X bar is equal to 3.666. What does that represent? Yeah, the mean. Now, we could verify that number if we wanted to, right? We could figure the average of that, but I'm going to assume that it's correct. Let's move on down. And the standard deviation I'm getting is 4.10%. 4.10%. Is that the correct answer? Okay, now, what if I had been really sneaky and instead I asked you to calculate the variance? What would you do? Yeah, we just square this number. So if I had asked you for the variance, what we would do is just square that number. Okay, question?
Just for clarification, are we going to use sample the whole test?
Okay, I will never give you a question that uses the standard population standard deviation from the calculator. Yeah. Now, I will give you population questions, but you'll recognize them because they'll be there's a probability of 0.4 for regular times and 0.6 for a depression or whatever. Yeah, so those will be on there, but I imagine we're going to run into those. Bless you. Run into those today. Questions? Okay. Number 7, a security with normally distributed returns has annual expected return of 16% and standard deviation of 24%. The probability of getting a return between negative 8% and 40% in any 1 year is. Okay, so the first trick to these things is figuring out how many standard deviations away we are with these boundary numbers. And the way we're going to do that is, well, you could say T or Z, I don't care. It doesn't matter if the calculation is the same here. So we're going to say minus 8% minus the expected return. What's the expected return here? 16%. Divide by the standard deviation. What's the standard deviation? 24%. Okay, so that's minus 24% over 24%, so that is minus 1 standard deviation. Okay, now let's make sure that this other one is plus 1. It says 40% minus 16% divide by 24%. What's 40 minus 16? 24. So this one's going to be plus 1 standard deviation. Okay, now what is the probability that exists between minus 1 standard deviation and plus 1 standard deviation? Yeah, 68.26%. In this case, we're using the exact. If we'd been using the approximation, you would have come up with 68%. And what would have been the closest answer? 68.26. Questions? Okay, so the first thing you need to know is on the exam, I will not give you anything other than plus or minus 1, 2, or 3. So I'm not going to mess with you that way. The only way I could be cruel, perhaps, would be to make one of them minus 2 standard deviations and the other one plus 1 standard deviation. But all you do is take the equivalent of plus or minus 2 standard deviations, divide it by 2, and add the equivalent of plus or minus 1 standard deviation, and then you have it. I don't know that I would be that cruel, though. Questions? Okay. Number 8. If the daily returns on the stock market are normally distributed with a mean of 0.05%, by the way, that's really low, right? That's tiny. And a standard deviation of 1%, the probability of the stock market would have a return of negative 23% or worse on one particular day is approximately. Okay, so we've got minus 23. This is another one of those T calculations. Minus 23, and then the minus 0.05 divide by 1. And so what we've really got here is 22.95, negative 22.95 standard deviations. Okay, let's walk this through. If with plus or minus 3, I've got 0.13% left in the tail. You guys remember that? Because it's 100 minus 99.74 divided by 2 gives us 0.13%. That's just with minus 3 standard deviations. Imagine what it is with minus 23 standard deviations. Damn near zero. Now, is it totally zero? No, but the closest answer would be 0. Is that the answer? The correlation coefficient between the stock and the market portfolio is plus 0.7. The standard deviation of return of the stock is 0.4%, and the market portfolio is 20%. Calculate the beta of the stock. This formula comes from the bottom of one of those charts that we've looked at, and I pointed it out when we went through the lecture. And that is beta sub I is equal to the covariance of stock I with the market divided by the variance of the market. Do we have covariance? No, what do we have? Correlation. And we use the substitution principle to see that it's the correlation of the stock with the market times the standard deviation of the stock times the standard deviation of the market divided by the variance of returns on the market. Now, there's some simplification we can do right now. What happens? Yeah, so this thing, whoop, and this thing cancel out. And so what I'm left with here is the correlation times the standard deviation of the stock divided by the standard deviation of the market. Correlation is 0.7 multiplied by the standard deviation of the stock. Yeah, and we could either go 0.4 or 40% because it's going to cancel out either way, right? So I think this is 1.4. Is that the correct answer? Very good. Number 11, suppose the beta of ExxonMobil is 0.75, the risk-free rate is 5%, and the expected market rate of return is 15%. Calculate the expected rate of return on ExxonMobil. What equation are we going to use to do this problem? Okay, you're getting close. We actually call it the blank blank line. Security market line. Security market line. And so our formula for security market line, that's exciting. Okay. expected return on the security is equal to the risk-free rate plus the beta on the security times the expected return on the market minus the risk-free rate. What's the name for this thing right here? Yes, the market risk premium. Now the question is, have they given us the market risk premium or have they given us the expected return on the market? Yeah, they've given us the expected return on the market. So we're going to have to go ahead and do the calculation over there. They tell us that the risk-free rate is 5% plus the beta is 0.75 multiplied by it's 15% expected return on the market minus 5% the risk-free rate. So this thing right here is 10%. 10% times 0.75 is 7.5%. 7.5% plus 5% is 12.5%. Is that the correct answer? Very good. Questions? Mr. Letterman, you hanging in there? Okay. Sometimes I look on students' faces and I see what I think is confusion, but it's just gas. It's like when kids, little babies, when they smile at you, it's just gas. Okay. Number 12. A portfolio is composed of two stocks, stock A and stock B. Stock A has a standard deviation of 35%, while stock B has a standard deviation of 15%. The correlation coefficient between the returns on A and B is 0.55. Stock A comprises 40% of the portfolio, stock B comprises 60%. The standard deviation of return on the portfolio is. Most common mistake here. Students go for that formula. I'll write it up here on the board. They're like, aha, this is the two-asset portfolio. So here we go. The variance on the portfolio, and tell me if I get the formula wrong here, is equal to XA squared variance of A plus XB variance of B plus 2XA XB covariance of A with B. Does that look right? Okay, now, have they given us covariance? No, what have they given us? Correlation. So most of the time, people will just stick that correlation in there for the covariance, and they will not know what's hit them. So the problem here is that we have to substitute. And if you remember, the correlation of A with B is equal to the covariance of A with B divided by standard deviation of A, standard deviation of B. So to get covariance by itself, so I can substitute for that, I'm going to multiply both sides by standard deviation of A, standard deviation of B. And so then I get that covariance of A with B is equal to the correlation of A with B times the standard deviation of A times the standard deviation of B. And so we're going to take this piece right here and we're going to substitute it in right there. Now, do you want to be doing all of that during an exam? No. You should have both equations on your note sheet. You should have both equations on your note sheet. Okay. Now that we have that all figured out, let's get our calculators out and figure this thing out. Let's see, that first term, XA squared times the variance of A. What is the weight on stock A? Yeah, it's 40%. But since we're using this inside of an equation, I'm going to go ahead and make it into a decimal. So those weights are always in decimals. What do we also know about the weights? They always have to add to 1. They always have to add to 1. Okay, so in fact, here's what I'm going to do. Since we have standard deviations already, I'm going to take the weight multiplied by the standard deviation of A, which is 0.35. And then if I square that, does it give me XA squared variance of A? Yeah. So I'm going to go ahead and square that. And I'm going to say store 1. Okay, I'm going to use the same technique for the second one. What is the weight on B? 0.6. And what is the standard deviation on B? 0.15 equal. And then I'm going to square that. And I'm going to store that in location 2. Okay, here we go for the big one. I'm going to take 2 times 0.6 times 0.4 times, what's the correlation? 0.55. They gave us that. Multiplied by that covariance, the standard deviation of A and standard deviation of B. So we're going to multiply by 0.435 times 0.15 equal. And we're going to say store 3. Okay, what should I do next? Recall 1 plus recall 2 plus recall 3. Now they're asking us for the standard deviation. What have we got here? Yeah, we got to take the square root because this is a variance, right? So we hit square root, and I'm getting 20.39%, which is this answer here. Is that correct? Cool. Oh yeah, this is just plugging and chugging. If there were a trick, the trick is recognizing that you were given correlation instead of covariance. And then the skill comes in knowing which formula to use. And so in this case, you'd be using the second one instead of the first one. And from there, it's just plug and chug. Now, I make it look easy. Do you know how I can make it look easy? I've been doing this a long time, right? I still screw up on these things. Do you think when you do a calculation like this, go ahead and work all the way through the exam, then what should you go back and do? Yeah, check your work. Check your work. My students from Asia are very good about checking their work. Americans, not so much. Are people from Ghana good at checking their work? Yeah. Yeah. He says yes, very confidently. She's like, okay.
So, you, just to clarify, that, the covariance, the top one.
Uh-huh.
Actually, no, never mind. I'm good. I figured it out on my own.
Sweet. Okay, any other questions? Okay, number 14. Your investment has a 40% chance of earning a 16% rate of return, a 50% chance of earning a 10% rate of return, and a 10% chance of losing 4%. What is the standard deviation of this investment? Read, this is going to be a portfolio standard deviation. Will we be able to do this quick and dirty using second 7 and second 8? No, no, we can't. So here's what we're going to do. We're going to have to do this the hard way. By the way, when you run into this one on the exam, skip it and come back to it. Come back when you're relaxed. Probability of that first state of the economy, so it's 40%, that the return will be 16%. And there is a 50% chance that the 10% return, and there is a 10% chance that it will lose 4%. What we say when we read lose, what should we do? Negative. Very good. So minus 4%. So far, so good. What's my next step? Find the expected return. expected return here is going to be 0.4 times 16% plus 0.5 times 10% minus 0.10 times 4%. Notice, bless you, I just took the minus off the 4 and put it out here. There's no magic there. So this is 6.4% plus 5% minus 0.4%. And so I think this is just 11%. Is that correct? Okay, now, how we're going to work this, we're going to find this deviation, which is the return minus the expected return. Phew, I can't write today. Return minus the expected return. And so 16% minus 11% will give us 5%. 10% minus 11% will give us minus 1%. And minus 4 minus 11 is minus 15%. Our next step over here will be to square that deviation. And then our final step will be to take the probability times that squared deviation. Now, the way to work these, I actually did something bad here. I started working down. Which way should I be working? Should always be working across. And after you see how it's done in the calculator, you'll understand perfectly why. Okay, so let's start from scratch and say 16 minus 11 equals. So we get the same 5%. Now, how do I go about squaring that? This was the easiest question all day long. Yeah, we just hit the square button, right? Boom! And that's 25. Now, the final step is to multiply that by the probability. What is the probability? 0.4, right? So I'm going to multiply by 0.4, and that gives me 10. I want to store this in location 1. Okay, now the next one is 10 minus the expected return of 11 gives us negative 1. I'm going to square that, gives us positive 1, and then I'm going to multiply it by the probability. What's the probability? 0.5 equal 0.5. So I'm going to store that in location 2. And then finally, I've got minus 4, negative, minus 11 equals negative 15. I'm going to square that. It gives me 225. Then I'm going to multiply it by the probability. What's the probability? Yeah, 0.1. Multiply by 0.1 equal, and I'm going to store 3. Now, what should I do to get the variance? Yep. Recall 1 plus, recall 2 plus, recall 3 equals. That gives me 33 variance. But it's not asking for variance, it's asking for standard deviation. What do I need to do next? Take the square root. Boom, I'm getting 5.74%. Is that the correct answer? Cool. Yeah, go ahead.
So I noticed that the 60% were whole numbers, they weren't percentages.
Okay.
Why is that?
Okay, so what you could do here is you could have written this 0.16, 0.10, and negative 0.04, and then done your expected return, and it would have come out 0.11. And then this deviation would be 0.05. This would be minus 0.01. This would be minus 0.15. And then these deviation squareds would be in decimal form. And when you got done, instead of having 33 for your variance, you would have had 0.0033. And when you took the square root of that, you would have gotten 0.0574. So the trick with decimals and percentages, if you're going to work in percentages, stay in percentages. If you're going to work in decimals, stay in decimals. If you don't know what the hell you're doing, convert everything to decimals, and then at the end, convert back. Because then you don't have to know, the reason I can do this is because I know what I'm doing, right? You might not. Good question.
So decimal, you could just keep it the same on percentages.
Yeah, as long as you just stick with one or the other. Oh, I do not ever use the percent button on my calculator. And I don't know why that is. It could be because I was trained as an engineer, and if we use that, they would burn our fingers off. This just creates additional. Now, if you know how to make it work for you, great. If you don't, just do the math. Let's see what happens if I take, let's see, 40. Is that the percent key? Percent? Yeah, so it changes it. Yeah, you could do that.
But whatever we use.
Oh, yeah, very much so. Other questions? Okay, number 17. A coupon bond pays interest of $80 annually as a par value of 1,000, matures in 5 years, and is selling today at a 75-25 discount from par value. The current yield of this bond is, so many people have trouble with current yield, but it's actually so simple. Can anyone tell me the formula for current yield? And so it's the annual coupon divided by the bond price. That's it. Okay, how much do they say the annual coupon is? 80. And they tell us that this bond is selling for a 75-25 discount from par value. What's par value? 1,000 minus that 75-25 discount. I'm going to go ahead and get my calculator up here and say 80 divide by open parenthesis 1,000 minus 75.25 close parentheses equal. I'm getting 8.65%. Is that the correct answer? Yeah. By the way, when a bond is selling for par, it's the only time this happens. It's really magical. Your yield to maturity, your coupon rate, and your current yield are all identically the same. But that's the only time that ever happens. Go ahead.
It matures in 5 years.
No. Oh, yeah. Okay, and students get upset with me because I give them more information than they need to solve a problem. And I tell them, hey, wait till you get into reality when you have less information than you need to solve the problem. Do you find in your work that you often have less information than you need to solve the problem?
I'm good at finding information. I have too much.
Oh, okay. Yeah, this is like when my wife and I try a new restaurant. It's terrible because she's faced with so many delicious choices and she's, whoop, right? But I always just go in and get the cheeseburger and we're all good. Okay, let's see. That was number 17. Now we're on to number 18. What is the taxable equivalent yield on a municipal bond with a yield maturity of 4.55% for an investor in the 35% marginal tax bracket? So hopefully you remember this formula right here. You guys remember that? This is the yield on the municipal bond. This is a yield on an otherwise identical taxable bond multiplied by 1 minus the marginal tax rate. This thing here is the taxable equivalent yield. Taxable equivalent yield. So we need to solve for that. I'm going to divide both sides by 1 minus t. So it gives me I sub t, the TEY, is equal to I sub t, no, I sub m, divide by 1 minus t. So the taxable equivalent yield is equal to I sub m divided by 1 minus t. And that's also known as I sub t. That's where I was going with that. Okay, what do they tell us is the yield on the municipal bond? 4.55%. So 4.55%, you could do this as decimals if you want. It'll work either way. Where percentages will not work is on the bottom. When I'm taking that 1 minus t, that's got to be a decimal. 1 minus, what's the marginal tax rate? 35%, so 0.35. And so I'm going to get my calculator out here and say 4.55 divide by open parentheses 1 minus 0.35 close parentheses equal. I'm getting 7%. Is that the correct answer? If you're lousy at algebra, should you put this rearranged formula on your sheet? Yeah. Number 19. A client in the 33% marginal tax bracket is comparing a municipal bond that offers a 4% yield to maturity and a similar risk corporate bond that offers a 6.25% yield. Which bond will give the client more profit after taxes? What is the after-tax profit on the municipal bond? Yeah, it's the same as the yield, right? Because you don't have to pay taxes on it. So all we have to do is figure out this equivalent for the 6.25% taxable. Well, if we go back to our formula here, we could say that's equal to 6.25% multiplied by 1 minus 0.33. Yeah, 33. Okay, so easiest way to do this is to say 1 minus 0.33 is 0.67 multiplied by 6.25, and that is 4.1875. What would you rather have, 4.1875 or 4%? Yeah, I'd rather have 4.1875. So I'm going to go ahead and buy this taxable bond. Now, do you think the decision might be different for someone in the 38% tax bracket? Yeah, if we do this math, in fact, let's do it. 1 minus 0.38 is 0.62 multiplied by 6.25. And now it's more attractive for them to buy the municipal bond. And that's why we say that people with high income are the ones that are more likely to invest in municipal bonds because they've got that higher marginal tax rate. Questions? Okay, that was 19. If the nominal rate of interest per year is 12%, the inflation rate is 5%, what's the real rate of interest? Anytime you hear stuff like this, you should immediately think of the Fisher effect. And the way we like to write the Fisher effect in this class is 1 plus big R, which is your nominal, is equal to 1 plus little r multiplied by 1 plus h. What's inflation? I mean, what's h? Inflation, right? Okay, now it's asking what is the real rate of interest. Which letter up here represents the real rate of interest? It's the little r, right? The little r. How do I get little r by itself? Yeah, I divide both sides by 1 plus h. So I'm going to say 1 plus r divide by 1 plus h. And when I do that, that puts 1 plus r by itself over here. One more step to get little r by itself. What is it? Yeah, we just subtract 1 from both sides. So I'm going to say minus 1, and then I will just erase this over here. Now, have I done anything to violate the laws of algebra? No. And it's not magic, it's just algebra. Okay, so now we've got our numbers. The nominal interest rate is 12%. By the way, when you're doing this 1 plus r or 1 plus h stuff, do we use decimals or percentages? Decimals, got to use decimals. So this is going to be 1 plus, so it's going to be 1.12 divide by 1.05, subtract 1. So we'll get our calculator out. 1.12 divided by 1.05 equals 1.0666. Then I'm going to subtract 1 and multiply by 100. I'm getting 6.667%. Is that the right answer? Now, what would the approximation have been here? Remember, the approximation is r is equal to r plus h. So the approximation would have been 7%. Is that also one of the choices? Yes. Will I do that to you on the exam? Yes. Questions? Okay. Yeah.
It's going to be clear that
Oh, yeah. And to the best of my recollection, I did not include anything asking about approximate. Because when did I tell you that's the only time that's okay for you to use approximate? At the bar with your friends, and you're just having casual conversations about real rates and inflation. So, no, I will not, to the best of my recollection, not be asking you that. Okay, number 23. A firm does not pay a dividend. Well, this is a good one. It is expected to pay its first dividend of 54 cents per share in 3 years. And then that dividend will grow at 9% indefinitely. What does indefinitely mean? Forever, right? Using a 10% discount rate to compute the value of this stock. So here's what I recommend that you do with this problem. I would start by drawing a picture. So this is year 3. And it says in year 3, it's expected to pay its first dividend of 54 cents per share. And then we expect that to grow at a 9% 9% indefinitely. Okay, now, if I ask you, so this is a 2-step process. First of all, we recognize that this is a firm with constantly growing dividends. And if it were starting at time 0, or if the dividend started at time 1, here's what we would say. We would say P sub 0 is equal to D1 over R minus G. Does that look familiar? Okay, here's the problem. Do we have D1? No. Where does it start? D3. So if I take D3 over R minus G, what does that give me? P2. Because this formula always gives me the price 1 year before that first dividend gets paid. Now, so I'm going to figure out P2 here using D3, and then I'm going to use my time value of money, either the calculator or you can use the formula, I don't care. But I'm going to take that P2, and I'm going to bring it back in time, 2 periods to time 0. And so that's going to make this P2 be a future value, and our P0 is a present value. So it's a 2-step process. So the first thing I want to do is figure out that P2. So I'm going to take 0.54, which is my D3, divide by open parentheses. What is R? 10%? Yeah, so it's 0.10 minus, what's the growth rate? 0.09, close parentheses, equal. So I'm getting $54 is my P2. And notice that's one of the choices. But that's not what it's asking. It's asking for the value of the stock today. Okay, how though am I going to get this back in time? Well, I'm going to say second, clear TVM. I'm going to put this in as a future value. And our required return is 10. That's 10I per Y. What do I put in for N? 2, because I had to take that price back 2 periods, right? And so I'm going to say 2N, and then what am I going to compute? Yeah, compute the present value. And I'm getting $44.63. So 2 steps, go ahead. No, and here's the problem. There is no D1, right? And if you did that, what you'd be finding is not only the value of those dividends that we're talking about, but then your 2 little fake dividends that you have magically developed would also be in there. And so the estimate of price would be too high. Oh yeah, we would all love to get around the rules of math, but it doesn't work. Questions? Okay. A firm has been losing sales due to technological obsolescence. Its projected growth for the future will be -%. Its recent dividend was $2. What is the value of the stock when the required return is 9%? Okay, first thing we're going to do is to try to figure out whether we've been given D0 or D1. Which one have we been given? D0, right? So if we're going to find P0, we need D1 over R minus G, but we do not have D1. What can we substitute in its place? Go ahead. D0 times? Yeah. So we're going to say D0 times 1 plus G divide by R minus G. Okay. Now, this is where it gets funky. The growth rate is -7%. What do most students want to do? One, they want to add that. They forget that it's a negative. You say, wait a minute, a negative growth rate? Who would want to buy a company with a negative growth rate? As long as we can find a positive present value for that company, there is still a price at which you'd be willing to invest. And that's what we're going to find out here. So let's figure this out. We've got D0 of $2 multiplied by 1 plus negative 0.07. Are you with me so far? Here's where it really gets hairy for students. What's the required return? 9? 0.09. And here's what students want to do. They want to say minus 0.07. Is that right? No, it's minus minus, right? It's minus minus. So that actually turns into a plus. Okay, so here we go. 2 times 0.93. Hopefully you can do that math in your head there. Divide by, open parentheses, 0.09 plus 0.07, close parentheses, equal $11.63. Is that the correct answer? Okay. Biggest trick on this one is this negative negative right here, turn it into positive, because most students want to make that 0.09 minus 0.07. By the way, do you think I would be cruel enough to include that as one of the choices? If I was feeling frisky that day when I wrote the exam, I would, right? If I had thought to. Okay. Ooh. Intech just paid a dividend of $2 per share. Analysts expect its dividend to grow at 25% per year for the next 3 years, then 5% per year thereafter. If the required rate of return on the stock is 18%, what's the current value of the stock? What kind of problem is this? So, well, it is TVN.
One of the cash flows. I forgot what it's called. Something that uneven.
It's super normal. It's not just normal, it's super normal. What does that mean? I have no idea. It's above the normal, I guess. It has above normal growth to begin with. Okay, now, remember the first thing that we do when we have one of these problems is to draw a picture. We draw a picture. So, here we go. We've got 1, 2, 3, 4, 5, 6, 7, 8. That should be enough. Okay. The first thing we need to do after drawing our picture is figure out what dividend they've given us. Have they given us D0 or D1? They've given us D0, but do we collect D0? No. Unless I tell you otherwise, and I never will, unless I tell you otherwise, we do not collect D0. The other guy gets it, just like we're going to collect the final dividend before we sell it at that time, at the end. Okay, now that means that it's actually D1 is where I'm going to be putting my first dividend up here. But the other reason it's important for us to know which dividend we're talking about is because they tell us they expect it to grow so much for the next 3 years. Since we've started at time 0 with that dividend, we're going to use the kindergarten method starting at time 0 to figure out where that start of constant dividend growth happens. And so we're going to say 1, 2, 3. So that start of constant dividend growth happens in year 3. Now we need to know, so our process is to find the individual dividends up to the start of constant dividends. That's our first one. And so we're going to have D1, D2, and D3. So that's the first step. The second step is to find a price at the start of constant dividend growth that represents the value of all the dividends that are going to happen from then until the end of time. And we're going to call that P3. And our CF keys, we're going to do this. C of 0 is how much? 0. C01 is going to be equal to, oh, well, let's not go with numbers here. Let's go with, so let's say dividend 1. What's C02 going to be equal to? 2, dividend 2. C03 is going to be equal to There's two things going on at time 3. What are they? Yeah. So we're going to say, and I'll run it the other way, but there we go. Okay. We can actually calculate those things in our calculator, keep all the numbers in there, and not have to worry about messing up re-entries and rounding errors. So I'm going to say CF second, clear work. CF0 is 0, C0, 1. Now, if D sub 0 is 2, and it's growing at 25%, how would I calculate D sub 1? D0 multiplied by 1.25. Very good. So D0, they tell us, is 2 multiplied by 1.25 is equal to 250. I'm going to hit enter, and then what else am I going to do? Store it. Store 1. Arrow down, arrow down. Now, what am I going to do? Recall 1 and multiply by what? 1.25 equal. Enter. What else? Store 2. Arrow down, arrow down. Recall 2 multiplied by what? 1.25 equal. Enter. Store 3. So now I have D1, D2, and D3. I need P3 though. P3 is equal to D4 over R minus G. Because remember, this formula always gives it to you one period in the past. But do we have D4? No. What do we have? We have D3. And that's going to be D3 times 1 plus, I'm going to say the second growth rate here, divided by R minus G, second growth rate. What is that second growth rate? 5%. So here we go. My first step is to multiply this number I've currently got on my screen by 1.05. 1 plus G2 is 1.05. Boom. That's actually our D4 right there. We don't care, but that's what that is. Divide by, open parentheses, the required return is 0.18 minus the new growth rate. What's the new growth rate? 0.05. Close parentheses, equal. That number right there represents P3. But is that the only cash flow that happens at time 3? No. So I've got to add back that D3. And where do I have that thing? Yeah, plus recall 3 equal enter. So I should have everything in there now. If I want to find the present value of everything that I have in my cash flow worksheet, what button do I hit next? NPV, very good. I hit NPV and it's asking for I. What should I put in for I? 18. Boom, boom, enter. Arrow down. Compute. I'm getting $25.94. Is that the correct answer? Very good. Who asked to see number 25? You guys, do you understand it now? Okay. You feel right now like you're 100% confident. What I want you to do is later work through both this example and the one that we did in class and make sure you understand, because they're a little different. Remember, the one we gave in class started at D1, and so when we did the kindergarten method, we moved from time 1. This one gave us D0, and so we moved kindergarten method from D0, but we did not receive D0, so it's a little confusing. Questions?
So if we did start at D1 as opposed to D0, would we have gone up to like we would at P4?
Yeah. If they had given us D1 instead of D0, it would have been 1, 2, 3, which would have taken us up to time 4.
Okay, so then you're getting all the way up to P5 to solve P4.
Yeah. But of course, we're not actually going to get D5. We'll get D4, multiply it times 1 plus the, yeah. Yep. If I've got dividends that start growing, or that start at time 72 and grow indefinitely from then on till the end of time, and I put it into the formula, what price am I going to get? I gave you the first dividend was at time 72. When does the price give us the value? Time. Okay. 72 years from now, after everyone in here is dead, most likely, right? 72 years from now, this firm is going to pay their first dividend. So that's D72. When I plug D72 into the formula, it gives me P71. Now, if I were then to take that and figure out what the stock was worth today, what would I do? I would treat that P71 as a future value, and I would use 71 for N, and I would compute the present value, and it would tell me what the stock was worth today. So, does it make sense to buy stocks that will not pay anything for your entire life? Yeah, because the value of those things is going to go up. It's just you're going to be getting all capital gains, no dividend yield. Questions? Okay, are there any? So right now it's 12:06. We theoretically have 9 minutes left. Do you want me to jump into the stock features? You do. Okay. So here we go. So last time we had finished slide number 3. We were on to this one. It says common stock features number 3. And this one is talking about the voting. Oh, come on. Talking about voting. Okay, so for elections, typically what you see is straight voting. So I'm talking about political elections. And we say it's basically one person, one vote, and so every person for every race gets exactly one vote. In a board of directors, you can also have what's called a cumulative voting system. If there are 2 people, if there are 2 current openings, then every share receives 2 votes. But you don't have to distribute your votes between the races. You can focus your votes on one. And so it allows minority shareholders, meaning those with small holdings, to elect a member to the board of directors. Let me explain to you why that's important. So I am the big block holder at the company. I have 50% plus 1 share. You guys own everything else. Now, I like Samuel to be the director. You guys hate Samuel. I put all my votes on Samuel. You put all your votes for the other person. Who wins? Yeah, I do. Actually, it's me because I'm the one, right? Okay. And then I have my second favorite. I like her. You guys do not. What happens? Who wins? I win. What we're getting around to saying here is even if we had a 12-member board of directors with straight voting, someone with 50% plus 1 of the shares can always elect all the board members. It doesn't quite sound fair because I have only slightly more than 50% of the shares, yet I'm naming every single one of the directors. Maybe I should only be able to name 7, and you guys should be able to name the other 5. If you want that kind of power, you invest in firms that have cumulative voting. In that case, with these, let's say we had these 2 races, that you guys would have a vote for each of those for every share that you owned. And you could actually pool all your votes You could vote twice for the same person. By the way, is voting twice in an election considered good in politics? No, that's considered cheating, right? But in this case, it's perfectly legal to put all your votes on one candidate, to vote for the same person as many times as you have shares times the number of positions available. So let's talk about what does that mean. First of all, why is it important that minority shareholders have representation on the board? If they don't, then what we have is the problem of the majority shareholder running the company for their own benefit. They'll run the company for their own benefit because they're humans. That's what humans do. And so what we want to do is to be able to get someone on the board. You say, wait a minute, that's a 12-member board. How can electing one board member possibly change things? Because you're picturing it in your head as a democracy where the vote will always be 11-1. But here's what you're not understanding about boards of directors. Do they tend to be populated with industry experts? No. They tend to be populated with CEOs of other firms and other industries. That's one of the constituents. And then the heads of large charities like the American Red Cross, and then retired military admirals, generals, that sort of thing. And then there's always a lawyer. There's always a lawyer. Okay, now, are these people intelligent and well-meaning? We'll give them the benefit of the doubt and say that they are, but they don't know much about what's going on in this industry. Who is their primary source of information about what's going on in the industry? The CEO. And so as the CEO, I can walk in and tell you fine folks a big, tall pile of bullshit, and you'll believe it because we golf together and our kids go to the same private schools. How about, though, if someone manages to get one person on the board that is an expert in the field and actually knows what's going on? For example, this is, we are Airbus. You guys know Airbus? Big European jet maker. Who's the primary competitor? Boeing. Okay. Well, let's say that this is the Airbus board of directors, and I am the CEO of Airbus, who I assume is French. So I will do my French accent. And I say, ladies and gentlemen of the board, unfortunately, the industry is in bad shape. So we are doing poorly. And you guys believe me. But then a minority shareholder manages to get someone named to the board. And that someone's name is Alan Mulally. Alan Mulally used to be the CEO of Boeing. Do you think Alan still keeps up with what's going on yeah. And now Alan's in the boardroom. And I, the CEO, walk in and say, oh, ladies and gentlemen, the industry is still in a bad way. So that is why we've lost money yet again. And at this point, Alan says, bullshit. Which is a nice way to say bullshit, right? And the CEO says, more? And Alan says, by the way, Boeing has had positive net income in the last 2 quarters. They're in the same industry as you. How come Boeing can do that and you can't? Right? Now, what happens to you well-meaning, intelligent people on the board? Are you any longer going to totally trust everything the French CEO tells you? No. In fact, you're going to say, let's see, Monsieur CEO, we need a moment to talk without you. And so we make him leave the room. I have to leave the room. And then you guys start peppering Alan with questions. And when I show back up, what do you think is going to happen? Do you still believe everything that I say? No. Now you're going to start to ask me some questions along with Alan, right? Do you think that's going to perhaps improve my incentives to perform well? Yeah. Oh, yeah. Because no longer am I able to blame See, if you've got something to blame and no one else knows any better, then it's all good. I'll give you an example. How long ago did COVID happen? It's been like 5 years. We still have people blaming COVID for their current performance. I'm currently doing performance reviews for junior faculty. And I'm like, you were still in high school when that shit happened. Why are you still blaming that for your current lack of success, right? And if that's true, then basically that means you will never be successful because you obviously are not going to be able to overcome this problem. So people will look for excuses, for things to blame. Having the outside director keeps that from being as big of an issue. Does that make sense? Okay, that's all we have time for today. By the way, there is a formula to let you know how many votes you need to be able to elect your very own director, and that's it right there. So start watching the stock features video at this point and watch it till the end. And if you have questions, send me an email. Okay, remember you've got the exam to do, and then you should have to have a safe spring break because I want you back to talk about Chapter 12.